Chapter 1. Mechanical Principles. Kinesiology. The study of the anatomy, physiology, and mechanics of body movement, especially in humans. Kinesiology, also known as human kinetics, is the scientific study of human movement. Kinesiology addresses physiological and mechanical mechanisms. Objectives: to apply the mechanical principles on human body movements. At the end of this lecture, you will be able to understand force, composition of force, what is point of application of force, resolution of forces, principles of compounding forces, tension. Force. Force is an agent which alters the state of rest of a body or its uniform motion in a straight line. Composition of the force.
One direction of force, represented by the direction of the arrow. To magnitude of force, represented by the length of the arrow. 3 point of application, by tail of arrow.
Compounding of the force. 1. Two forces acting in same direction and at a common point. 2. Two equal forces acting at a common point and in opposite directions. 3. Two unequal forces acting at a common point and in opposite direction. Tension. System of forces tending to separate parts of the body combined with equal and opposite forces which hold the parts together. Unit: Newton. Mechanism of positions. 1. Gravity. 2. Center of gravity. 3. Line of gravity. 4. Base. 5. Equilibrium. 6. Fixation and stabilization. Gravity. Gravity is the force by which all bodies are attracted to Earth. Newton's explanation: force of attraction existed between all material objects, and the magnitude of attraction was 1. Directly proportional to mass of each body. 2. Inversely proportional to square distance between the bodies. Direction of gravitational attraction of Earth towards the center of Earth and acts continuously. Force of gravity on human body. 1. What will happen if the gravity is unopposed? 2. Who opposes the force of gravity? 3. What if the opposing force is greater than force of gravity? If unopposed, the person will fall to the ground. Effects of the gravity can be counterbalanced when a force equal and opposite to it is employed. For example, 1. Support of plinth. 2. Buoyancy of water. 3. Isometric muscle contraction. If opposing force is greater than gravity, movement will occur in the direction of that force. Examples: heel standing. 1. Can be raised from ground by the contraction of calf muscles. Force greater than gravity. 2. As long as the force remains equal to gravity. 3. Heel will be lowered to ground if meter per second relaxes. Anti-gravity muscle. In erect position, the balance is maintained by the integrated action of many ms, predominantly extensors. True relaxation can only occur under conditions in which the meter per second are no longer required to work against the effects of gravity. Center of gravity of a rigid body is the point through which the Earth's attraction effectively acts, whatever the position of the body. That is the point through which line of action of weight acts. Examples: 1. Uniform rod.